In this video, I'm going to talk about the meaning of this notation of limits. To do that, I'm going to use this example which says if f of x is equal to x plus 3, find limit x approaches to 1 f of x. And this is equal to limit x approaches to 1 x plus 3 by just putting the value of f of x. To solve this limit, I'm going to use the direct substitution method as this function is defined at this point. So it is 1 plus 3, which is 4. Here we can see that the limit could be solved by just putting the value of x in the function. Then what is the significance of this notation, which says limit x approaches to 1? For that, I'll make a table x f of x now x is approaching to 1. That means the values of x are very close to 1 from both the sides. X is approaching to 1 from the left side and from the right side. So we can take the values which are very close to 1, like 0.9. If we go more closer, 0.99, 0.999, and from the other side 1.1, 1.01, 1.001. Now when x is 0.9, f of x is 3.9 by putting the value of x in this function. When x is 0.99, f of x is 3.99, 3.999, next 4.001, 4.01, 4.1. Here we see when x is approaching to 1 from both sides, f of x is approaching to 4 from both sides. X is approaching to 1, then f of x is approaching to 4. If we see it graphically, this is x, y, which is equal to f of x. Here is somewhere 1, 4. Now this is a linear function, so the graph of this function will be like this, a line. Now here we see when the values of x are going closer to 1 from both sides, the values of f of x are going closer to 4 from both sides. Or we can write it as limit x approaches to 1, f of x is equal to 4. We can use either of these notations. And in general notation also, when x is approaching to a, f of x is approaching to L. That means when the values of x are very close to a, the values of f of x are very close to L. Or we can write it as when x is approaching to a, f of x is approaching to